Hello, Selamat Hari Raya. So today I would like to talk about MiniProject2. So in MiniProject2, we are asked to create a DRAM controller which will store data in the allocated address in the selected memory bank. So let's talk about the input and output of ports. So clock, reset, ALE, address in, read, write, data, and IS and CAS, which is the main input output. So the ALE so ALE is the input which will enable the controller to run. So when ALE is 1, the circuit will run, the function will go. Otherwise, when the ALE is 0, nothing will happen. And then address in is the desired address of the user. It store the both row and column and the desired bank, which is why it is 9 down to 0. And then read and write is the function, and data is the input and output. Data we will explain later. And IS and CS. IS is the signal to enable the RAM to tag in the address out from the controller, as the row address. CAS is the otherwise, is the signal to enable the RAM to take the address out from the controller as the column address. And then write enable is an input in RAM, output in controller. Overall, it is the signal to determine whether to read the data from the selected address or to write the data into the selected address. Yeah. So this is top level. So let's go to controller. So before that, I would like to show you the stack diagram. So the stack diagram at the left is the stack diagram of the controller, and right is the stack of the memory banks. So the stack of the memory bank is dependent on the controller. So initially the controller is at idle, so it will wait for ALE becomes 1, and then until that, before it equals to 1, it will stay at idle. So at 1, it will go to the control state. So at control state, it will get address in and read and write the signal. So the right enable signal will be determined in the stack control state already, but it will only output at the end, which is at the last step. So after that, we will go to state row. So the address out will be the address in of 7 down to 4, which is the row address. It will output to every single memory bank. Yeah, but it will not be registered until the IS send is equals to 0 is sent to the selected memory bank. Yeah. So when IS equals to 0, the address out will be taken. Yeah. And then same in the column stat and the CAS stat send. It's just that it becomes the column address. And then at last, we have the stat right enable send. So if you send the right enable signal to the operation, and then if right enable is equals to 1, right enable equals to 1, the data will be stored into the selected address. Otherwise, when right enable is equals to 0, the data in the selected address will be outputted, and then they will return to idle. So we can see in the controller here. So the step initially either wait for 1 and then the next step will become control. So at control, the address buffer will take in the address in, and then the write and read pattern will decide the write enable output, which is currently stored in the write enable temporary. So row, the address out will be the 7 down to 4 address buffer. Address in. Yeah. For simple set, I will just set address in. Address out will be the address in of 7 down to 4, which is the row address. And then at ISN the 9 and 8 bit of the address in will decide which bank is chosen. Yeah. And the pattern is determined in the following this table. And then same in the column and CSN, it's just that it becomes 3 down to 0, the address in, which is the column address. Sorry, I drink a water. Which will be the column address, and then the write enable will be send, and then CS will be send. Yeah. So let's go to RAM. So at the RAM module, we have a 2D signal RAM, which is the 2D matrix 2D address. So every time the process begins, the data will be cleared with this will be cleared with data equals to z. Yeah. So case state. So either if we wait for RS equals to 0, and then it will take in the address out, the address as the row address. And then if it goes to CS wait SAM, it will wait for CS equals to 0, and then it take the address as the column address, 3 down to 0. And then operation, if you see whether it is right or write enable equals to 1 or write enable equals to 0. When equals to 1, the data is stored into the RAM, the address. Otherwise, when write enable equals to 0, the data inside the RAM, the address, will be outputted to the data. Let me explain again. So the data in the address of the RAM will be outputted when write enable equals to 0. When write enable equals to 1, the data will be stored into the RAM, the address of the RAM. Yeah. Okay, so let's move on to the test bench. Test bench, yeah. This is the test bench of controller. So we will see whether the address are correct. Yeah. We will see whether the address in are correct, and yeah. So as we can see here, the address in is 1111 until 10. So the expected output will be the row address is 1111. Yeah, here. And then the row address 1111, the column address 1110, and then the first two bit is 11. So the selected bank is the third bank. Yeah. And then we have right and above, of course, because the WR is high. Yeah. So the secondly, the address is 1010 what. So this is the expected address out. This row, this column, the first two bit is 10, so the selected bank is the second, yeah, active row, right? And then it's a write function, so the write enable is high, and then the rest is read function, so there is no, the write enable is low. So this is the this is the address in. This is the row and column address are correct. The first bit, the first bank is selected. Yeah. The bank 0 is selected over here, and the address are correct. So let's see the test bench of the RAM. Yeah. So in test bench of RAM, we will write the data into the address, into this address, and then we will read the data from the address. Yeah, and then we will do it 2 times with different data and different memory. Write and read, write and read. Is this the right one? Wait. Okay. So it's the address is 11111111. Yeah, so this is the address. Column 1111, row 1111. Yeah. Okay, so the address is correct. So initially we write the 0101. So and then when we read, we get the result. Yeah. Write, read. Write and equals to 1, write and equals to 0. When we click over here, we can see the data is same. So we can safely say that the data is stored into the address and then is read into the address correctly. So the other way, this is the wait. Yeah, the next address is 11111110. 11111110. So RAS, so it's red, the row is red, and then the CS is red, and then the data is written into the address. Same here, the address is red again. This is the row, this is the column, and then it is a read function because write enable is equals to 0, and then we got the same we got the same output. So the data is written and stored correctly. So, and then let's move on to the test bench of the top level. We do the same thing, it's just that we do not directly control the write enable. We use the read and write signal, and then we have ALE to control. So the oops, wait a minute. Okay, so the address is this 111 111 and then is a write function, and the data is this, and then when we read, yeah, zoom in a bit, is stored in this data is stored in this address, and then when we read from the address, yeah, this address, we get the same same data, 10100101. Yeah, same here. This is the address selected. Yeah, this is data 01010101, same data. So I think it's safe to say that we created the controller based on the requirement of the data sheet. Thank you.